Tell us about the Minmetals Capital South China Tower.
Well, it's actually not a very tall building.
Mm-hmm.
It's 30 stories, and I'll be presenting at the end of today.
Mm-hmm.
The unusual part of it is that there are notches or setbacks in the facade, and that created challenges because of the Chinese code.
How so?
Well, the Chinese code, regardless of where the building is located, requires you to have two lateral systems, two lateral load resisting system, and one normally on the facade and one in the interior core. And since our facade has this offsets, we could not have the bracing go around in plane, but we had to offset, zigzag it around the setback in the facade.
So you've worked on projects all over the world. How does the structural engineering code change from country to country, and how do you navigate that when you're working in various countries at any given time?
Well, we try to convince the developer owner to adopt the IBC code, which is what we're most familiar with. In some countries, we are quite successful with that, but not in China. I mean, China has its own codes, and some of which are very different from the US or the Euro norms.
What are the challenges there? I mean, how do you get them? What's sort of the pushback that you get when you try to get someone to adopt the IBC code? What's that conversation like?
Well, they say, it's different here. We have our own requirements here, and we have to follow them. China is a very big country, so the regulations have been written by various experts, but it seems to us that it could be pulled together more uniformly and more realistically. It's some areas very conservative.
Do you think as we keep seeing projects be increasingly international and tall building booms are happening in every continent, except Antarctica, I guess, that will be more standardized when it comes to code? Or do you think countries will get more individual?
We would hope that it would become more unified so that there is one international building code with the local seismic and atmospheric conditions being applied, because the wind storms in Hong Kong are very different than in Singapore, where the wind does not blow, and the seismicity of a local region affects the design of the building enormously, and so that should be recognized. But then to pull it together and have one set of criteria, which is then more engineers can design across the globe and actually to a more uniform safety factor.
How has the work of structural engineering changed since you began your career?
The use of computers.
Yeah.
That would be the biggest change. But the Empire State Building was built in a floor a week. The design is still robust. The use of computers allow more engineers to do more crazy things, more twisting, turning, curving buildings, more three-dimensional structures, which are being also directed by the architects and the developers. Everybody wants to have the building stand out.
Yeah, and it sounds like it's almost getting more intertwined. Structural engineers are doing design work, and designers are doing structural engineering work, essentially.
Yeah.
And that's because of computer-assisted design.
Because of computers. Now you have to work very closely from day one with them, particularly if it's very three-dimensional structure.
What sort of possibilities does that create for you as a structural engineer, maybe in doing some design thinking? What sort of new possibilities does that open up for future designs for you?
Well, we would hope that with the advent of computers and more architects getting more involved in the 3D aspects of structure, that more of the structure would be expressed and not hidden away. I mean, I'm speaking as a structural engineer, right, who wants to see the structure more visible to the layperson. So when you walk by a building, you wonder what makes that building stand up, or where is the structure. It would be interesting, more interesting to people.
Are there some buildings right now that you think do a good job of that, expressing the structure in a beautiful way?
Well, the most obvious would be bridges, because in the bridge, the structure is the architecture. We did the Miho Museum Bridge in Kyoto, outside of Kyoto, and there the bridge is the structure, and it is also the architecture. But the Bank of China Tower in Hong Kong, for example, also has the bracing all expressed on the facade. And that was from the 80s, so that was not too usual back then. A lot of architects would have just cladded over it and not express the bracing, but IMP chose to express them. He says, to show the strength of the building.
Yeah, or I think back in Chicago of the John Hancock Tower, which also shows the structure.
Bracing, yeah.
What are some of the key challenges going forward, you think, for structural engineers, especially as we get taller and taller, as we get denser? What are some of the things that you see as big challenges in the future?
Well, it's not so much a structural challenge, but more a challenge to work together with the architect and the developer to create buildings which are more user-friendly, more sustainable, and really sustainable, not just to meet some written criteria to meet LEED Platinum, but to make it more habitable.
What's the structural engineer's role in that? Because, I mean, I see definitely from a perspective of embedded carbon, just how much material you're using to execute that structural engineering solution. But what other ways does structural engineering have a central role to play in sustainability?
Well, the materials, the advance in the strength of materials has been enormous. But at one stage, particularly like now even, there's no point in using even higher strength material, because, particularly for a tall building, because it's not really governed by strength, but by its performance in the wind, in the earthquake. So how people respond to the movements. So when you use too high strength materials, the building becomes more flexible. So then you have to put in dampers to balance out the accelerations for a tall building. So in a sense, there's no need to advance the strength of materials anymore, but to find ways to make the building more sustainable. Well, we have used so little material today. I mean, building structures are very efficient now. I think it's more got to be associated with the MEP building services, the curtain wall, so that the building uses less energy in its lifetime.
Yeah, lifetime, not just the construction.
Not just the construction. I mean, most high-rises use composite steel and concrete. And steel is from recycled materials. Concrete has a high carbon footprint, but is getting much, much stronger.